Hello and welcome to Beamer. This is all about being a fun project that will hopefully cost pennies. If, like me, you have a number of these very cheap synthesizer boards that are probably used in toys mostly, I should think, I thought I'd make an effects unit based upon them. As you can see, I've actually got a collection of 3 types of these boards. The first and largest is called a C for cat, K for kick 9561, and that can produce a number of sounds including car alarms, sirens, ambulance bells, etc. Quite a few different sounds. The next one is called an H for Harry, S for sugar, -088, and that just simply provides a doorbell type sound. The third one and latest, I've only purchased this recently, I think it's only become available recently, is called a P for Peter, X for X 85, and that produces serially many types of songs and tunes. These are so plentiful that I've mixed all 3 for both the left-hand channel and right-hand channel. So there are 6 in total being used. And of course, this is a stereo effects unit. This effects unit doesn't drive speakers. It actually drives a line drive. So you can plug it into, say, an amplifier. And both the CK9561 and the PX85 can be adjusted via potentiometers to change their speed. I've conditioned all 3 boards' outputs to effectively drive into a summing type mixer configuration. And should you wish to, you could develop this project into incorporating its own stereo power amplifier to drive speakers and make the mixing more comprehensive. Following now is an audio sample of what it can do. I haven't let the PX85 go on too long simply because there might be a copyright risk issue. And by the way, this makes a lot of noise. I must apologise. Halfway through that audio sample there was some scratchiness. This was due to a jump lead being a little intermittent. Moving on now to the breadboard and its power supply, which is at the top left hand side. It is derived from a 12.5 volt lead acid battery via a polyfuse 100 milliamps, and using a 78L05 it provides a 5 volt supply and a 3.9 volt reference voltage. Now moving over to the right, we have the first soundboard. Let's call them all soundboards rather than synthesizers, and it's the CK9561. This is the left hand one, and just above that we have its associated speed control potentiometer, and just to the right of that left hand sound card we have the right hand CK9561, and above that its associated speed control. To the right of that, and more or less centre of picture, is the LM324. This contains 4 op amps, 2 of which provide 3.9 volts DC supplies, and the other 2 op amps provide left and right summing mixers. Now moving over to the right breadboard and a little way down, we come across the first PX85, and it's the right hand sound card. Now to the far right we have its associated speed control potentiometer, and slightly further down we come to the left hand PX85 with its associated speed control potentiometer being far right and almost at the bottom of the page. Now moving to the next sound card down, which is the second card up from the bottom, we come across the right hand HS-088, and finally moving down to the bottom sound card we have the left hand HS-088. Now let's move back up to the top of that breadboard. You can see 2 wires protruding out to the far right. The white upper one with an L is left output, and the lower orange one is naturally the right output, indicated by an R. Now for the final and most important breadboard. In the lower centre of the picture is the patch block, and this controls everything. I almost forgot to mention the green vertical wire, more or less in the centre of the picture, is in fact 0 volts. That is 0 volts for the output cable, the line cable, and 0 volts for any scoping you might want to do. Here we are at the circuit diagram stroke overall block diagram. As this diagram is quite large, I decided to horizontally break it up into 3 sections. So here we are on section 1, and let's go to the far left hand side, the power supply. For the sake of noise immunity, I tend to always use a lead acid battery, and this is why the DC input voltage here is 12.5 volts DC. As a lead acid battery can provide anything up to 30 amps DC, I always fuse as close as I can to the terminal to ensure that that fuse will blow, and I set that fuse at about 2 amps, 2.5 amps, but nevertheless for an electronic circuit even that is quite high, hence the reason why I use an additional polyfuse set at 100 milliamps. This effects unit really uses 2 voltages. One is 9 volts and it's regulated, and the other is 3.9 9 volts DC, which is not used as a supply, it's used simply as a reference voltage. Now we have a high efficiency LED, hence the reason why the resistive dropper is 33K. The next component here, which is D1, is reverse protection. If the supply were to be reversed, this would go into conduction and the polyfuse would heat up and open up. Then we come to C2, which is a decoupling, and a Zener diode next, which is 3.9 volts DC. IC1 is a 78L05, and that is jacked up by the Zener diode. So if that's 5 volts and that's 3.9, you're really looking at a supply voltage here of 8.9 volts DC. Then we come to R4, which provides the current for the Zener diode, and we're looking at C4, which is a capacitor which will just reduce any noise that the Zener diode might make. Then we arrive at C5, which again is a decoupling capacitor. Now we come to 2 op amps here, which represents 1/2 of the LM324, and they provide 2 power supplies of 3.9 volts DC, so current can be drawn from these 2 points here, which doesn't affect the supply of the Zener diode 3.9. The capacitor here, which is C6, and of course C8, they're identical, are there to smooth out any noise on the output of the op amps. But of course it's not wise to put 100 microfarad directly on the output of an op amp. So to prevent any instability that might cause, R5 and R9 are in place. They're 47 ohm resistors and don't affect the voltage supply at all, not at these currents anyway. A supply provides supply voltage to approximately half of the overall circuit, and B supply supplies the other half. I've basically split them, mainly to distribute the load, and I ended up with 1 spare op amp that I thought I would use for this purpose. Should you want to minimize the components of this design, you could omit R5, C6, R9 and C8 and directly connect the supply output to the output of the op amp. It should work. Now moving on to IC4, which represents a summing mixer. All 3 outputs of the sound cards come into, that's 1 channel, and I think this is the left hand channel, come in at this point here. There is a little bit of high frequency reduction on the negative feedback by C9, and the overall gain of this circuit is about 0.8, 0.9, so it doesn't amplify. This actual circuit is a reduction circuit. The output from the sound cards are actually quite high. C11 blocks the DC component driving to the line output here, and R12, because this is an electrolytic, I've taken it down to 0 volts. The supply to the summing mixer is plus 9 volts, and all of this represents the left hand summing mixer block, which is absolutely identical to the right hand one, hence the reason why I haven't drawn it in. It's just a block diagram with its right hand line output at this terminal here. There is something about a summing mixer to do with amplitude that is probably worth noting, and that is because there are, in this particular case, 3 inputs coming from 3 separate sound cards, and say for example each card is producing 1 volt peak to peak, and if this op amp was set to unity or a gain of approximately 1, with one sound card producing just 1 volt, then the output here would be 1 volt. If 2 sound cards were producing 1 volt, then the output here would be 2 volts. If all 3 sound cards are producing 1 volt, the output here would be 3 volts. And you need to be aware or conscious of that, because when all 3 are in operation, if all 3 sound cards were in operation, then you could be driving the output here into clipping, whilst if only 1 sound card were in operation and the other 2 were not, then the volume here of 1 volt might sound too low. I've shifted now to the middle section of the circuit diagram, and these are the block diagrams of the sound cards. Starting on the far left, we have the block diagram for the sound card CK9561 and its associated components. This is the left hand one, and the right hand one doesn't have the circuit diagram in it, it's just purely a block, but it's absolutely identical to the left hand version. This sound card takes its supply from the 3.9 volts DC supply A, and the supply takes us down to this pad here of the sound card, and capacitor C1 is its decoupling capacitor, which has to be very closely placed to the sound card. 0 volts comes to this pad here on the sound card, and these 2 components here, here's the potentiometer, the speed potentiometer, and these effectively go to these 2 pads on the sound card here. This is a low impedance line, whilst this is an extraordinarily high impedance line, which is very much affected by hand capacitance. If you have, say, metal casing on your potentiometers, it's worth taking those down to 0 volts to minimize those effects. Now this is the output pad going into these 2 components in series. This line here goes to the left hand summing mixer input line, and R3 sets the amplitude level on the output of this sound card. Now these 2 pads here on the sound card, this one here and this one here, control the effects that this sound card generates, i.e. car alarm, ambulance, siren, that sort of thing, and they go to the patch block. The output line here also goes to the patch block. Right, that's the left hand side. The right hand side here is absolutely identical to the left hand side, and these 3 lines here are identical to these 3 lines. The only difference being is that one's left hand and the other one's right hand. Just a thought, it could be possible to exploit the sensitivity of this speed control with, say, a touch control, which would have a very dynamic changing effect to the sound effects generated. Moving on now to the PX85 sound card. This time the supply is taken from B supply circuit, that's a 3.9 volts DC, and this supply line goes to this pad here on this sound card. Apparently there was no need for a decoupling capacitor, and 0 volts is taken to these 2 pads here, this one here and this one here, whilst its associated speed control components, these 2, This potentiometer here, VR2, and its associated resistor are across this pad here and this pad here. The output from this sound card is taken from this pad here and has a 4K7, that's R6, pull-up resistor. This is in place of its normally used loudspeaker position, and the output to the summing mixer is taken via these two components here and via left-hand patch block. R7 sets the amplitude from the PX85. That's the left-hand side. The right-hand side is absolutely identical to the left-hand side, but I haven't drawn it here. All I've got is a block square, and its right-hand output goes to the patch block. And finally, now moving on to the last sound card, the HS-088. Its supply is taken from the B 3.9 volts DC supply, and if you follow the line down here, you end up with it being connected to this pad here. A 0 volts is taken to the right hand pad here and one end of R13. And because this sound card is effectively a doorbell, it needs to be triggered, and it's triggered by these two components, that's R13 and C12, and that's taken to the patch block so that you have a push button to activate it. The output to this sound card is taken from this pad here via these two series components. R11 sets the amplitude of this sound block, and the output waveform effectively goes to the summing mixer input via patch block. The right hand version of this is absolutely identical, like the others, absolutely identical to the left hand circuit. The two lines to the patch block are identical to the two lines on the left hand side. That's the only difference between them. One is left and one is right. Finally, we've now come to the last section of the circuit diagram. This is a simplified circuit diagram of the patch block. A fuller explanation will be presented shortly. Please ignore these words here. They belong to the section above on the circuit diagram and are not relevant to this discussion. Starting on the left hand side, we have the control wires to the CK9561, and they come down to these 4 points here. These two wires are for the left hand side and these two wires are for the right hand side. To control the sound effects, all you have to do is move this wire here to either the positive supply or indeed to 0 volts, or similar to a tri-state, left open, and the left hand two wires control is identical to the right hand side here. It's probably worth mentioning at this point that except for the HS-088, which is effectively a doorbell, all the sound cards are running continuously. So therefore, if you want to bring in the sound effect of the CK9561, you need to connect up the output from that sound card to the input of the summing mixer, and you do that by lifting this wire here and moving it over to that wire there. And these two wires are the left hand side and these two wires are the right hand side, which is identical. This procedure is the same for the PX85. If you wish to connect that sound card through to the summing mixer, all you have to do is move this wire here to that point there, or in fact the green spot here really. That will bring in the left-hand sound effect, and it's identically true for the right-hand side. All you'd have to do is move this wire through to that green spot there. So this connection pad system is exactly the same as this pad system here, except for different sound cards. Now we come to the HS-088 doorbell, and all you simply do here is, say for the left hand wire, if you lift the left hand wire and touch it to the green spot here, which is the positive supply, the doorbell will ring, and it only rings for a short period of time, like a one shot, and then you have to connect it again. And that is true for both the left hand side and the right hand side. Now we'll move on to what this looks like, this patch block looks like in practice. These are the control wires for the CK9561, left pair, right pair, and you move those to the supply, which is the red rail here, or you can move it down to 0 volts, which is the blue rail here, or lift them off completely, and that's the third open option. And what I do is I move them down to these sockets here, which of course represent open circuit for the control wires. Now we move on to that CK's, the sound card, left and right output select option, simply by moving this white wire here, which is the left channel, to either connect by putting it into this rail here, or not by leaving it where it is. And that's true for the left channel and or the right channel. The same procedure is applicable to the PX85 output select options. On the left hand side here we've got this wire here, and if you want the output sound of that sound card to be delivered, you just have to move that wire from that position there to just one over, which will make a connection with the other two wires, and PX85 will sound. And this is true for the right hand side as well. It's identical. Now for the HS-088 doorbell emulator. You have here a supply, I don't know whether you can see it, but you've got a supply link here, means that this rail here is positive, is a supply. And all you have to do is take this wire here, which is the left hand wire, and lift it and just touch it onto this rail, anywhere along here, onto this rail here, and the left hand doorbell will sound. And that is true for the right hand here as well. And there we are, that's the patch block exclamation finalized. And incidentally, the yellow vertical stripe here is just an elastic band that holds the breadboards down. If you've lasted this long in the video, well done, thank you. And should you make this project, I hope you enjoy doing so and using it. Oh, and please don't forget to like, share and subscribe. Thank you very much.